This project focuses on refining a design into a high-fidelity working prototype that clearly communicates its product value proposition. Using human-centered and UX methods, I iterate, test, and finalize designs through 3D printing, Arduino, and Unity. This project represents the final phase of my design process. Developing a high-fidelity VR controller tailored for Sail VR, the aim was to create an intuitive, ergonomic, and immersive controller designed for seated, rotational gameplay. Through a human-centered design approach, this project demonstrates how thoughtful interaction and usability can transform digital experiences into a more natural, embodied one. The Sail VR controller was developed from early research insights into a high-fidelity working prototype. It balances comfort and simplicity, supporting intuitive movement and minimal hand strain. The final Concept 2 design achieves natural control without overwhelming users, allowing them to focus on the sailing experience rather than the technology in their hands. The design process moved from rapid sketch ideation to low-fidelity prototyping, and finally into a functional high-fidelity model. Early sketching allowed me to explore proportions, hand positions, and overall form language that aligned with the sailing context. The lo-fi prototypes focused on testing ergonomic comfort and how users naturally held and interacted with the object. This stage revealed small adjustments in grip, angle, and button placement that greatly improved intuitiveness. The final hi-fi prototype brought all these refinements together, integrating electronic components like sensors and Bluetooth to demonstrate a working proof of concept that embodied both function and aesthetic resolution. A human-centered design approach guided every stage of this project. I began identifying user pain points, such as fatigue, restricted movement, and cognitive overload from excessive controls. Through iterative feedback, I refined the controller to prioritize comfort, accessibility, and intuitive feedback loops. UX methods such as journey mapping and physical testing supported decisions that made the product feel more mindless, something users don't have to think about while using. It becomes an extension of the body, not a barrier between the user and the virtual world. To define the context, I studied existing 3DOF controllers such as the Oculus Go, Pico G2 4K, and the Google Daydream. These devices rely on rotational orientation rather than full positioning tracking, making them perfect for seated or stationary experiences like flight or sailing simulation. I identified their advantages: lightweight design, low power, and simplicity, but also their limitations, such as reduced accuracy and limited physical immersion. Understanding this balance shaped the function and design of my own prototype, ensuring it met Sail VR's interaction needs without overcomplicating the interface. Comparing existing products helped refine my design direction. Oculus controllers focus on comfort and immersion through balance and button placement. PSVR 2 introduced adaptive triggers and finger touch detection for more tactile response, while Unia VR focused on minimalism and easy grip. By studying the differences, I identified the combination of their best qualities: ergonomic curvature, reduced visual clutter, and accessible input mapping. These insights ensured my design aligned both functionally and visually with the established language of professional VR hardware. The technical system within the prototype was developed using an Arduino board, gesture sensor, and Bluetooth BLE module. Together, these allowed for motion detection and wireless communication with the VR system. Building this functionality was key to bridging physical form and digital performance, turning design research into working prototypes. The internal layout was planned for balance and comfort, with each component arranged to maintain lightweight usability. This integration highlights how tangible prototyping and the UX thinking can merge into a cohesive, interactive product experience. Ergonomic refinement was central throughout the development. I considered hand anatomy, grip width, and wrist posture to minimize strain and enhance control precision. Prototypes were tested for both comfort and intuitive reach for buttons and triggers. Material exploration involved lightweight polymers and soft silicone grips, improving tactile feedback and slip resistance. These design decisions encourage longer, fatigue-free use and make controllers suitable for a wider range of users. It embodies inclusivity through form and texture, offering a balance between functionality, comfort, and aesthetic clarity. A, B, X, and Y buttons, trigger buttons, independent free hand movement, comfortability, VR-compatible features, and a safety strap. These are all arranged to promote independent and comfortable hand movement. The aesthetic draws inspiration from contemporary tech minimalism, blending soft curves with clean lines and muted finishes. This gives it a professional, seamless appearance that aligns with Sail VR's calm, focused atmosphere. Every detail, from proportion to button placement, was designed to communicate simplicity, elegance, and intuitive control, enhancing both visual appeal and overall user experience. This project represents the culmination of research, iteration, and testing to achieve refined high-fidelity prototype. It demonstrates how ergonomic refinement and minimal design can enhance immersion in 3D OF environments. More importantly, it showcases how human-centered design transforms technical challenges into opportunities for empathy, accessibility, and creative innovation. The Sail VR controller not only reflects functional success, but also deeper understanding of how design can bridge the physical and digital, shaping technologies that truly feel human and intuitive to use.